Hi everyone, in this video I want to talk about domain and range of both rational and polynomial functions. This is a topic I've seen on the ACT before where they will ask about domain and range as well as bring up the topic of asymptotes and zeros to make sure we don't take ourselves too seriously. Let's talk about our fun question. What has been one of your most enjoyable vacations in your life? So to understand where all of this falls in the grand scheme of everything on the ACT, it's under Algebra 2, and we're doing a little bit of rationals and a little bit of polynomials here. So in this one, you are given graphs, which would be common. The first one, you can tell it's a rational function because it's a fraction. Rational numbers are numbers that could be expressed as a fraction. Okay, so a rational function has asymptotes and zeros. Polynomial function just has zeros. Okay, what are these two things? Well, an asymptote is this line that's sort of like a boundary line. Believe it or not, there's another one right here too. It's hard to tell with this diagram. So we are first going to talk about domain and range. Then we'll get into the asymptotes and zeros. Okay, domain and range. Domain, all the x's. So think about how many x's do you see in this function? Okay, in order to do that, we should probably think about this function factored. We need to get down to all of the smaller pieces of these, the top and the bottom here, the numerator and denominator. I can take out a -3 on top. This is a topic from Algebra 1, factoring that's got a greatest common factor on top. And we have a trinomial to factor on the bottom. That's x plus 4x minus 3, right? Because what two numbers add to 1? Multiply to -12. Okay, so I can tell that my domain is going to be everything except where this fraction doesn't work, okay? If you set the bottom equal to 0, you will not have it work. It's going to be all real numbers except at -4 and 3. And I can see that on the graph. I can see it right here and right here. There's something funky about the graph in those spots. Okay, so the way that I want to indicate this is that the domain is from here to here. Okay, we got -infinity. Remember, that goes out to -infinity, all the way up to -4. Okay, now this is interval notation. I also want to note that it's from -4 up to the 3. So I'm going to do a union with -4 and 3. Okay, because this is in pieces. Notice I'm basically just taking out the -4 right here. The parentheses indicate that it does not include the -4. Then I'm going to do a union with the 3 and on this x-axis. Okay, so you're thinking about it's everything except those two numbers. You're extracting the -4 and the 3. You also could write that in inequality notation, but interval notation I think is more common for the ACT. Okay, range. This is all y's. So range would be how many y's are represented on that in that function. Okay, so you can see it's all everything from here up to here, and then there's a little break, and then here up to there. So you're looking at the other number line this time. Range is going to be all reals except 0. Okay, there's this dotted line at 0. So that is -infinity to 0, not including the 0, union with 0 up to infinity. Okay, so we're extracting the 0 once again. Now, one thing that's interesting about this one is there's a hole. I don't expect that you'd see a hole on the test, but I included this just in case. X plus 4s, they actually cancel here. And so that tells you for rational functions where your hole would be. It's going to be at -4. Then you plug in the -4 to find the y. It's going to be at a point right here on the graph. Also, the break in the graph, this asymptote, is where the function, it's like a break, it's a boundary line. So we have asymptotes at the VA, vertical asymptote, is at x equals 3. There is another one, there is the HA, horizontal asymptote, at y equals 0. Okay. There are no zeros for this graph. A 0 is an x-intercept, so we actually have none for this one. Number 2 is a polynomial function, and this W-like formation is actually going to expand out this way. So my domain is actually going to be -infinity to +infinity, because that is going to stretch far and wide, all the way to negative and positive infinity. Range, you'd think would be the same, right? But it actually goes as far down as -4, but then as far up as infinity. So we're going to say, instead of a parenthesis, which is singular for parentheses, instead of a parenthesis, we want a bracket. So we want -4 up to infinity. Infinity you can never actually touch, but remember that brackets indicate that you are actually touching an actual point at that -4. So which is why we all of a sudden need a bracket for number 2. Are there zeros for this one? Yes, they are here, here, and here. It's where they cross, where the function crosses the x-axis. So that is at, we'll put set notation here to indicate a list, -4, -2, and 0. Now, moving on, there are some practice problems right here. Feel free to pause the video if you'd like to try them before I reveal the answers. For the first one, we need to factor it out and write domain, range, and asymptotes. The second one, just domain, range, and zeros. Before I leave you, I want to discuss one of my favorite quotes. Great works are performed not by strength, but by perseverance. At school, we like to talk about the growth mindset, meaning that if you put your mind to something, that you can really become better at whatever task that is. And so this, I think, is fitting for when we learn things that are difficult. Before we part, I want to remind you that if you could subscribe to my channel, I would really appreciate it if you want to see more videos. And don't forget to leave a comment with the answer to the fun question. Have a good day. See you soon.